Okay. Uh, Good afternoon, everybody. My name is Devi Rahman, and today I'm going to discuss about open channel flow. So at first, I will define open channel flow, and then I will also discuss about the classifications and how open channel flow is differs from pipe flow. That's what I will discuss today. So, do you have any idea about open channel flow? Can you give me an example of open channel flow? Any types of flow like river flow or channel, these are the open channel flow. So let's see what is the definition. Basically, the name implies the definition. It is open channel flow. So we know water is transported from one location to other location by natural channel or artificial channel, or even we use pipe to transport water, right? So the cross section of these channels or pipe may be open at the top or it may be closed. If the surface is open, then like this section, it is closed conduit, or the surface may be open like this. So if flow occurs through this channel, we call it open channel flow. Even if flow occurs through this closed conduit, sometimes we call it open channel flow. So what is the condition for a flow to be open channel? There are two conditions. The first, the surface needs to be at atmospheric pressure, and the flow will occur under the influence of gravity. That means the flow will occur only from higher elevation to lower elevation, right? So what is then pipe flow? So if the flow occurs in a closed conduit and if the pressure is more than atmospheric, so this situation only occurs if this closed conduit is full of water and if it flows from extra pressure, that means it has a gauge pressure, then we call it pipe flow. So this is the basic difference in between pipe flow and open channel flow, right? The surface needs to be at atmospheric pressure and flow will occur under the influence of gravity. So here is some examples like natural rivers, creeks, or even flood flows. These are the examples of open channel flow. So these are natural open channel flow. So what will happen if flow occurs through a pipe? So pipe or any designed channel like rectangular cross section or trapezoidal cross section. So these are the example of artificial open channel flow. Here we can see the natural river has irregular geometry, like this one. So why we need to know whether the flow is open channel or it is a pipe flow? Because open channel flow has different sets of equations and pipe flow has different sets of equations. For analyzing this flow and for determining the flow parameters like velocity, the flow rate, discharge, and the depth of water or the depth of flow, for calculating or determining this type of parameter, we need to know whether the flow is open channel or it is pipe flow. See, there are some artificial channel. The section is trapezoidal here, and this is the practical image you can see here. Or you may be seeing some kind of structure which is a regulator or closed conduit like this, which is culvert. So flow occurs through this closed conduit. So these are some artificial channels where open channel flow also occur. And this is the simple equation which can calculate the total energy at a section. So according to Bernoulli's principle, total energy at a channel section like this one here, the total energy is measured in terms of height. So what is the total energy? According to Bernoulli's principle, total energy will be the summation of elevation head, the pressure head, and the kinetic energy, which is called velocity head, right? So at this section, the total energy will be G plus Y plus V square by 2G. So this is the total energy at this section. This is how we can measure the total energy at a section, and we can apply the same equation at any other section or location, and then by comparing these two locations we can easily calculate the head loss, and by calculating this head loss we can design the channel or any type of structure, right? So far I have defined open channel flow and pipe flow. So do you understand now what is open channel flow and pipe flow and what is the difference between them? So let's see the types of open channel flow. So there are two criteria for a flow to be open channel. So like this, there are also two criteria for the classification of open channel. So first one is the time is the main criteria. If the flow parameters like velocity, discharge, depth of water, or the depth of flow, so this is constant over a specific time period, then we can call it the steady flow. Otherwise, if this parameter changes with respect to time, then we can call it unsteady flow, right? And there are other types of open channel flow, so where space is the main criteria. If this flow parameter, like a 1 kilometer length of a river, if velocity, depth, and flow rate changes over this length of a channel, then we can call it non-uniform flow, because flow is not uniform at all locations over this channel section or channel reach. And if these parameters are constant, then we can call it uniform flow. That means everything is uniform all over the channel reach or channel sections. So if flow varies over length and time, then sometimes we call it gradually varied flow and also called rapidly varied flow. If this flow parameters changes rapidly, then we can call it rapidly varied flow. Otherwise, if this parameter changes with slow rate, then we can call it gradually varied flow. So let's see the situation where gradually varied flow and rapidly varied flow may occur. So for example, Niagara Fall. Before falling the water, what happens? The river or the creek is in a situation where flow is uniform. There is no such type of flow in the real world situation, but for the simplicity, we assume the flow is uniform so that we can easily apply our equations for calculating these flow parameters and designing the structures and other things. So before coming to the free fall, the flow is gradually changing, right? Changing its direction, its velocity, and its depth of flow as well. So at this location, the flow is gradually varied flow. And after that, when the free fall occurs, so what happens? It drastically changes its velocity and other parameters, right? So then it is called rapidly varied flow. And after that, yes, and after that flow will also be a gradually varied flow. And finally, after reducing some energy, the flow will be also uniform flow. Yes, so far what we have done today, the definition of open channel flow. What is the definition? If the surface, the free surface is open to atmosphere and the pressure is at atmospheric pressure, and if flow occurs under the influence of gravity, then we can call it open channel flow. Otherwise, if flow occurs in a closed conduit and if there is a pressure which is more than atmospheric, then we can call it pipe flow or pressurized flow. And the definition of open channel flow and pipe flow. So after knowing this, we know the types of open channel flow, which is uniform, non-uniform, where space is the main criteria, and we also have steady flow and unsteady flow, where time is the main criteria, and we also have a gradually varied flow and rapidly varied flow. Right? So this is for today. So do you have any question? You can ask me any question regarding this or anything. Yeah.
Yeah, just want to make sure if the flow is not uniform,
Yes.
we cannot use the equation you mentioned.
We have a specific equation for uniform flow. If the flow is not uniform, then the calculation is more complex. Then we apply basically the solution of partial differential equation. That's why there are some extra parameter in our mathematical model. So we cannot calculate manually. Then we use mathematical model in computer.
All right, thank you.